Let's talk about homogeneous differential equations. A differential equation is homogeneous if it was in the following form: y prime equal f of y over x. Now, y prime should be isolated on one side of the equation, and the expression of x and y on the other side of the equation, which is always a combination of y over x. An example on that, the equation being homogeneous could look like y prime equal x squared over y squared, or y prime could equal cosine y over x minus x over y. So these are some kind of examples on the way the homogeneous differential equations looks. Now let's take a quick example on how to solve a homogeneous differential equation. So we have x y prime equal y squared over x plus y. Solve this homogeneous differential equation knowing that this equation is not linear nor separable. So firstly, we start with, as we spoke before, you start to isolate the y prime on one side of the equation and the rest of the xy expressions on the other side of the equation. In this case, we have y prime after dividing over x. Let's change the color here. So let's divide over x for this side of the equation and divide over x for the right side of the equation. So y prime will equal y over x all squared plus y over x. Now we assume the y over x to be a certain variable so that it will make it easy for us to handle the equation and find the final solution. In this case, we will say let u equal y over x. Now putting that back in the equation, since we have u assumed to be equal y over x, this means y equal u multiplied by x, and y prime equal x u prime plus u. So we plug the u as a replacement for the right side of the equation, y over x representation, and we move this expression, the y prime, we replace it with these values. This will give us the new form of the main equation. So y prime in this case equal x u prime plus u equal u squared plus u. And this result to have like u from both sides of the equation. Let's change the color. So u from both sides of the equation will be eliminated. If we move u to the right side of the equation, it will be minus u plus u will be eliminated. So in this case, we are lifted with x u prime equal u squared. Replacing the u prime with du over dx. So we have x du over dx equal u squared. Having the u and du, the u function and du on one side of the equation and the x function and dx on the other side of the equation can be done by having 1 over u squared du equal 1 over x dx. Now, in order to get the u value, we integrate both sides of the equation. So integrate both sides of the equation, and the result will be minus 1 over u equal ln the absolute value of x plus a constant c. From that, we can obtain the u value equal minus 1 over ln the absolute value of x plus c. Now going back, so we know that the u over here equal y over x. Now putting the value back in the form of y over x, so y over x equal the right hand side of the equation, minus 1 over ln the absolute value of x plus c. Now we multiply, so we multiply cross multiplication for both sides of the equation in this case. So y as a final solution equal minus x over ln the absolute value of x plus c. And this is the general solution of the original homogeneous equation.